Going to space, since the time of von Braun, is going to very harsh, difficult environment, characterized, for instance, by high dose of ionizing radiation. Radiation from the sun, radiation from the galaxy, from the various parts of the universe, to which humankind is not designed to resist. We have to protect from radiation, both on ground, on Earth, where the doses are very small, but particularly in space, where the doses are very high. So far, most of the missions have been short, few months, and protected by the Earth, by the magnetic field, and so the exposure to large doses of radiation has not so far been a very serious problem. But in the future, there are plans to go to Mars, to re-establish a base on the Moon, even to travel to asteroids and try to use the asteroids for application in space. So it's absolutely necessary that we cope and we deal with the radiation in space and find a way to protect the astronaut against that. The first thing which comes to mind is to use passive protection, amount of material which intercept those particles, reducing the radiation in the same way like the atmosphere protects us from cosmic rays. Unfortunately, the amount of material which is needed for passive shield is very large, too large to be effectively put in operation in space. It would require a huge amount of material, of masses, to be launched from Earth. For this reason, we have to change strategy and to search for means which are actively shielding particles and protecting astronauts, in particular using superconducting magnetic field. In a certain way, the Earth does the same. The magnetic field of the Earth contributes to shielding away particles from the galactic flux of cosmic rays. So in this case, we use superconductors, special superconductors which are particularly light, which can operate at intermediate temperature for long period in space and create strong magnetic field around the habitable module of the astronaut to bend the particles away and to protect the astronaut, reducing the dose they are exposed to by a significant amount, allowing them to travel for years in space, not just for months, going to Mars, going to Moon, and similar projects. Of course, this is an ambitious project. It requires new technologies or improvement of the existing technologies, very light superconductors, very strong materials to stand the force of the magnetic field, capability to integrate this in space, a cryogenics which can keep all these materials cold enough so for superconductivity to be operational, a number of technologies which have been developed, integrated together in a way which can be launched and operated in space. The Space Radiation Superconducting Shield, this project which I am coordinating for the European Union, attempt exactly to do this kind of optimization, using existing technologies, understanding to which level these technologies can be used to design within next few years an active shield. And most important, that this project is identifying the needed technologies for even more effective active radiation shield, requiring pushing the limit of those technologies to new levels, both in superconductivity, material sciences, and cryogenics, so to develop this technology for a next iteration on a longer time scale. We will not be able to go to space for extended amount of time, to go to new planets, unless we are able to cope with the radiation. The goal of this project is exactly that, to make an important, significant step in the direction of protecting the astronaut which travel for long exploration mission in deep space.